Good afternoon. My name is Alain Salvador Conejo Dávila. I'm a PhD student in the Research Center of Material Science, and I will present my research with the title Development of Ternary Polymeric System with Photoconductive and Semiconductive Segments. Photoconductivity is an optical and electrical phenomenon in which a material becomes more electrically conductive to the absorption of electromagnetic radiation. This process starts with absorption of radiation, continues with excitation of LUMO electrons, then the formation of movable charge, and finally the charge recombination. For polymers, the charge recombination occurs through p-conjugated system. Polyvinyl carbosols is a thermoplastic polymer with photogeneration properties. It only absorbs in the UV range, but is employed in electrophotography, organic light emitting diodes, and photovoltaic devices. Sometimes it will be mixed with semiconductor materials to develop photoconductive systems. Polyaniline is a conjugated polymer which optical and electrochemical properties are determined by oxidation state and if it is doped or not. This semiconductor polymer was employed to develop supercapacitors, colorimetric system, and as a transducer in electrochemical sensors. The general objective of this research is to generate a terpolymer system, which was constituted by a fraction of polystyrene sulfonate, which was functionalized with anilinium ion. This ion acts as graph point to propagate polyaniline change. Also, the terpolymer presents a second block of polyvinyl carbosols. The presence of polyvinyl carbosol and polyaniline in the terpolymer system, which produce a photoconductive system which could be employed in elaboration of solar cells. The methodology to elaborate the terpolymer system is the next. We start with conventional solution RAF polymerization using sodium styrene sulfonate as monomer, and a post-functionalization process using aniline. This to produce Macromex agent polyanilinium styrene sulfonate. In a second step, we elaborate a block copolymer using carbosol in a heterogeneous polymerization using water, toluene, and ethanol as a co-solvent. Finally, using the block copolymer and employed interfacial oxidative polymerization, we graph the polyaniline change to create the terpolymer system. Structural characterization of ternary system and its intermediate products. To elucidate the structure of Macromex agent, we use NMR spectroscopy and FDER spectroscopy. The proton NMR spectrum shows the aromatic protons of benzene sulfonate substituent, also the aliphatic protons of polymer backbone, and the aromatic protons of anilinium ion. If we compare the integration of anilinium ion and the benzene sulfonate, we can deduce that only the 50% of polymer was functionalized. To complement the elucidation, we use FDER spectroscopy. The spectrum shows the band of nitrogen-hydrogen bond of anilinium ion. Also, we can observe the classic bands of carbon double bond carbon of aromatic system. Also, the stretching of sulfur oxygen came from sulfonate substituent. Based on this, we can confirm the formation of macro agent. Compare proton NMR spectrum from macro agent to blocopolymer. We can observe the presence of new aromatic signs, which correspond of aromatic proton from carbazole substituent. These signs overlap with protons from anilinium and styrene sulfonate. Nevertheless, the integration of all these confirmed the presence of anilinium styrene sulfonate and vinyl carbazole in the structure of copolymer. Also, we can observe the presence of aliphatic protons came from backbone. To complement the elucidation of blocopolymer, we compare FTER spectrum from macro ion and conventional polyvinyl carbazole with blocopolymer. We can observe that blocopolymer present the signs of macro ion as nitrogen-hydrogen stretching bond, the band of sulfonate group, and aromatic signal. Also present the conventional vinyl carbazole bands, which are symmetric and asymmetric stretching of nitrogen phenyl bond, which are this and this. Based on this, we can confirm the blocopolymer formation. The polymer system is insoluble. To this, we cannot realize or analyze by NMR spectroscopy, but employed FTR spectroscopy, we can observe the signs of quinoid ring and benzoyl ring, which are classic from polyaniline formation. Compare the ternary block with copolymer block. We can confirm the formation of ternary system, which contains a styrene sulfonate, a carbazole substituent, and change of polyaniline. Optical properties. The optical properties of polymer was studied through UV-VIS spectroscopy. We can observe that conventional polyvinyl carbazole only absorbs in UV region. Also, the macro agent, which is in blue color, absorbs in the UV region and in a short part of the visible region. The physical mix of both don't present absorption in other region that this presents. By other hand, the blocopolymer present absorption in UV region and a wide range of visible region. This is attributed by p-stacking conformation that can adopt any vinyl carbazole and anilinium ion. Also, the formation of dimers through substituent in the third and sixth position of carbazoles with anilinium or between them. Compare blocopolymer with ternary polymer. In optical properties, we can observe that ternary polymer present a wide range of absorptions that include UV region, visible region, a part of the near-infrared region. This is because the presence of polyaniline change in leucoamyldin salt state, which presents an equilibrium between polarons and bipolarons, which produce the conductive properties that polyaniline present. The future work for this research is prove the conductivity and photoconductivity properties of the system, also study the processability of them, and try to use the terpolymer system in the development of solar cells. As a conclusion, through the rough polymerization was developed an amphiphilic system which, after an oxidative polymerization process, produced a terpolymer system which presents absorption in UV-VIS-NIR range of electromagnetic spectrum. This system presents in their structure a photogeneration and semiconductor segments. All these properties make it an interesting candidate to develop solar cells. I thank CONACYT for financing this project and for the scholarship award to me. Thanks for Simon and thanks for your time.